Right, welcome back to the Statistics and Probability course. Uh, Today we will still be talking about central tendency, but I would like to start by relating it to the material last week. So if you still remember last week, we talked about the central tendency in form of range, variance, and uh, median mode, and also standard deviation. Now, please do not forget about the variance and standard deviation, especially standard deviation, because that is something that we will carry over until the very end of our period, but also it will be very, very useful in um, predicting and calculating a lot of statistical analysis that you will come across later on in your academic life. Now, what's different then from today's material and last week's material? Well, the difference is that we will now expand a little more of our understanding on the different way of looking at the data. Again, when we talk about central tendency, it means we talk about the position of one particular data or one group of data in the given data set. So today we will be talking about um, percentile, quartile, and interquartile, and we will also talk about coefficient of variation. It actually is supposed to be the coefficient of variation supposed to be delivered last week, but I put it here so that we can have more variation of the central tendency. And besides, last week was already full. uh, I think there was already enough of last week's material. And we also talk about the z-scores, and we will briefly talk about the shape, skewness, and kurtosis. But we will break down the videos into 4 parts, so at least 3 parts, I'm sorry. So we will talk about the percentile, quartile, and interquartile in one video, and then the coefficient of variation and z scores in another video, and the shape, skewness, and kurtosis in another video if possible. Okay, let's start. So, percentile. What is percentile? It is a special type of statistic known as a sample 100 percentile, where p is any fraction between 0 and 1. So you have to think that when we talk about percentile, it basically starts from 1 to 100. Percentile basically um, divides the data set into 100 parts. Now, in human words, percentile indicates the value below which a given percentage of observations in a group of observation falls. For example, the 20th percentile is the value or score below which 20% of the observations may be found. If you say the 30th percentile, that means there are values below which 30% of the observations may be found. And the rest of the data set, which is 70%, are found above the 30th percentile, equal or greater than the 30th percentile. Uh, Still confused? It's all right. When we get to the calculation, you will automatically see it right away. And note that the sample median is the same sample 50th percentile. Percentiles are commonly used to report scores in tests so that the test takers and administrators can compare the scores. So percentiles are very uh, useful and also easy to apply, but I would like to emphasize more on its use. Uh, I tend to use percentiles when I want to describe my data set in terms of the distribution of the scores. For instance, doing an IQ test, and then I would like to know who falls below the 50th percentile, that is the median. If you still remember, median is the middle value, but you have to order it from the lowest to the highest scores, and then there you can see uh, where is the uh, middle value. But you can also apply the formula that we covered in 2 weeks ago. Now, again, go back to percentile. Percentile is very useful when it comes to describing uh, the distribution of your dataset. So, if you were to ask me, sir, what is the average of the class scores? Well, who falls or which scores fall below 50th percentile and which scores go above 50th percentile? By applying the percentile calculation, we can easily find out which scores and who are them are below 50th or above 50th. And it doesn't always have to be the median, or it can also go when you say, I think I did good on the test. Will I fall above 90th percentile? That means 90th percentile. So the highest the percentile, that means the higher the percentile, the higher the score is. So when you say I'm on the 90th percentile, that means you did really good, because 90% of the test takers fall below or equal to your percentile, and only 10% of it, and only 10% of the test takers fall above your score, which is 90th percentile or equal to 90th percentile. So that's how we think of percentile. Now let's get down to the calculation. How to determine the sample 100th percentile? We must first determine the data value such that at least n times p. So n is the sample size and p is the percentile of the data values are less than or equal to it. And at least n 1 minus p, n times 1 minus p of the data values are greater than or equal to it. We have some kind of rules here, so let me use this. If np is not an integer, so it's not a rounded value, then the only data value satisfying these requirements is the one whose position is the smallest integer greater than np. So for instance, we want to sample 90th percentile. Again, 90th percentile is quite high score from a sample size of n equals 12. So we got n equals 12. You see here, you go back to this, the first one, and p. Since p, we are interested in the percentile of 90th percentile, so p equals to, you have to convert it to decimals, 90th percentiles, that means divided by 100, so that's 0.9. We have np, n times p is 10.8. Now, it's not an integer, so what do you do? What do you do is the closest integer to 10.8 is 11, right? So here, 0.1, the data value that are the at least 10.8 or at least 11 values are less than or equal to it. So the data value must be in position 11 or higher. So 11 as a result of n times p is the data position or the score position. So the scores that are positioned below 11, that means that they are below 19th percentile, and the scores that are positioned higher than 11th position, that means they are higher than 90th percentile. And don't forget the second point, at least 1.2 values are greater than or equal to it. So it must be in position 11 or lower. So that's the percentile. And again, if you're still confused, it's okay. Take it slowly. maybe it's also my fault not explaining it very comprehensively, but once you get to the calculation, you will immediately figure out, okay, what percentile means, what percentile identifies, and how you uh, conclude based on the percentiles that you found. Okay, to find the sample 100p percentile of a dataset of a size of n, this is the steps that you need to take in order to calculate the percentiles. First, you have to arrange the dataset in increasing order. So that means when you have, let's say you have a dataset of 7, and then you have 9, and then you have 2, you have 4, and you have 1. These are the scores, right? So this is 9. So you have to arrange the data in increasing order. So 1 should be the first, 2 would be the second, 4 would be the third, 7 would be the fourth, and 9 would be the fifth. So that's good. Now you're good to go to the second point. That is, if NP is not an integer, determine the smallest integer. So that means you have to apply the formula n times p. Now, let's say you want to figure out the 70th percentile, right? 70th percentile. So the sample size is 5 because there are only 5 scores. So n p, that means n times p, 5 times 70th percentile, that means 0.70. So you just calculate, and you will end up with 3.5, right? Now 3.5 is not an integer, so this is what you're interested in. Determine the smallest integer greater than np. Okay, so that means 4, right? The smallest integer greater than the np, greater than 3.5. Okay, so we got 4. What does it mean? That means the 70th percentile is on the 4th position. Again, you have to go back to the data set and look the ordered array of data. So 1 is the first position, 2 is the second position, 4 is the third position, 7 is the fourth, and 9 is the fifth. Now we got fourth. So 7 is our 70th percentile. So whoever scores below 7, below the fourth position, that means falls below the 70th percentile, and whoever scores above the 70th percentile or the fourth position, then they score above the 70th percentile. Okay, now I hope you are getting a hang of it now. I think it's getting more obvious. Now here, let's calculate this together. Which data value is the sample 90th percentile when the sample size is 1 is 8, 2 is 16, and the third one is 100. So let's 8 first. Again, there is no data, but we can always figure out which data value is the sample 90th percentile just by looking at the sample size and the percentile that we are interested in. And then when we have the data, we can just go to the data set and then see which position is the 90th percentile. But first, we have to figure out the NP first, n times p. So 8, again, the sample size, times 0.9, right? So that would give us 7.2. Again, if NP is not integer, then you should convert it to the smallest integer greater than NP. So we got 8. There you go. So that's the first one. And let's do the second one. We got 16 times the same. We are interested in the 90th percentile, right? So 16 times 0.9. So we got 14.4. So that means the 90th percentile is positioned in the 15th dataset. Again, this does not refer to the score, but it refers to the position in a dataset, the 15th position, the 8th position. So here, if you look at it, the first one, the 90th percentile is the 8th position. That means the highest value, because there's only 8 scores, 8 scores in a dataset. Then the 90th percentile happens to be the 8th position. That means the 90th percentile is the highest score in a dataset. Now you calculate the 100. So 100 times 90, it will give us an integer. So if you see 100 times 90, it will give us 90. So that means the 90th position in a data set. Now it is an integer, right? So we have to look at the third point. If NP is in an integer, then the average of the values in positions NP and NP plus 1 is the sample 100p percentile. So what do you do? I got 90, so NP plus 1, 90 plus 91 NP plus 1 divided by 2. So 90.5 is, or 91 is the sample of the percentile. Okay, so that's how you calculate the percentile. And again, it is very interesting to use percentiles because percentile allow you to divide the data set into 100th parts, and it enriches your description of the data. You can just simply say the 90th percentile, or let's say the people who score above the mean, the average, or the median, are how many people. You just calculate the 90th percentile based on your sample size, and then you go back to the data and you see where is the position of the 90th percentile in your data set, and then from there you can give some kind of a mark. So data value or score that is on the 90th percentile gives you a border who goes below and who goes above, and how many score below and how many score above. So that's a good thing about percentile. And now let's then move on to quartile. Quartile is a measure that breaks up a data set into 4 parts. So you have to imagine like this. It's a data set, right? Imagine we have these are the patterns of the data. So here is the first quartile, that is 25% of the data values being less than the first quartile, and it's the second quartile. I should put this in, there you go, Q1. So anything that goes below this line, it means fall below the first quartile. Anything that goes below the second line, that means fall below the quartile, the second quartile. And this is the third quartile. Anything that goes below the third line is it means it goes below the third quartile, and anything that goes after the third line, that means it goes after the third quartile. So you can actually look at this. So this is actually the 50th. The second quartile is also called as the 50th percentile. So when you are asked, calculate the 50th percentile, so you're actually calculating the second quartile too. And 50th percentile, as we talked about, it is also the sample median. So it is also the median. Now this is the 50th percentile, and the third quartile is actually the 75th percentile, and it is the 25th. So when people ask you, can you calculate the first quartile? Yep, that's actually the 25th percentile. Can you calculate the 50th percentile? Yes, that's actually the second quartile. Can you calculate the third quartile? That is actually the 75th quartile. Okay, now find the sample quartiles for the following 18 data values, which represent the ordered values of a sample scores from a league bowling tournament. So I have ordered the data set in an increasing order from smallest to highest. Now find the sample quartiles. So you have to find the Q1, Q2, and Q3. How do you do it? I haven't discussed anything about calculating the quartiles. Well, like I said, this is actually the 25th percentile, right? And this is actually the 50th percentile. And you can also do it by calculating the median. And this is actually the 75th percentile. So just by knowing how to calculate the percentiles, you can actually calculate both things, the percentiles itself and also the quartiles. So go ahead, do it on your own. I hope we get the same answers. Now, interquartile. Interquartile is, I think it's more straightforward than the other two. This is another indicator of the variability of the data set that is equal to Q3 minus Q1. So the difference between 75th and the 25th sample percentiles, that is the interquartile. It just gives you the range from the 75th to the 25th. It does help you in describing the data when you have some kind of extreme scores, or when you have when you don't have a normal distribution of your data set. So for instance, a lot of people actually fall below the 50th percentiles, then you can actually, and then only a few people scored above the 75th percentile, and the scores, the difference of the scores between the 75th and 25th are quite high. So then it's nice to also talk about the interquartile range to kind of give the people a description of the variability of the data, as well as the position of the data, the certain values in the data set. So that is about percentiles, quartiles, and interquartiles.